All right, ladies and gentlemen, this is for 3.1, 3.2 solving systems of equations for Algebra 2. So the initial cost for Travis and his band to record the first CD was $1,500. Each CD costs $4 to produce. If they sell their CDs for $10 each, how many must they sell before they make a profit? So the equation for the cost of the CDs, so it's just going to be X equals $1,500, where X is what their cost was. Cost them $1,500 to make it. Equation for the income of the CDs, this is going to be $10 times X. So I'm sorry, hold on, let me rephrase that. That's going to be $1,500 plus $4 times X, where X is the number of your CDs. So the equation of the CD would be that. So where this crosses is nothing more than where I break even and how much money it would take me to break even. So the fact that it crosses at $250 and $2,500 tells me that they got to sell 250 CDs and make $2,500 just to break even. So systems of equations. There's two more equations to solve with the same variables. So the three ways to solve the system of equations are substitution, elimination, and graphing. Those are my three ways to solve. So the types of solutions, here's what I can have. I can have one solution, which is consistent and independent. I can have infinitely many solutions. What happens there is nothing more than you end up with a mathematical truth. You end up with something like 7 equals 7. And all that tells you is that it's the same line. And my last option is no solution. And if I'm solving using substitution or elimination, one thing that would happen is I would get a mathematical lie. I would get something like 4 equals 2, which is never true. So that's my tip off that there's going to be no solution, or it's going to be considered inconsistent. So solving by graphing. So now taking a look here, all I'm going to do is graph these two. So the first thing I'm going to do is take this top one and I'm going to subtract 2x. So I'm going to have negative 2x plus 5. So I start off here positive 5, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. That's going to be where my line is. And the other one, x minus y equals 1. Well, if I subtract x over, that's negative y equals negative x plus 1. Now, can't leave it like that. So if I switch that to y, I also need to switch all the other signs. Basically, it's taking both sides by negative 1 and multiplying it. So x minus 1 is right here. Slope will be here. Where do those two cross? Well, they cross right here at 2, 1. So here, this gets a little bit messier. So this top one, bottom one's nice. Bottom one's already in slope-intercept form. Top one, if I subtract 5x over, I get negative 5x plus 7. Divide by 4. So y equals negative 5/4 x plus 7/4. So now, but here's my big tip-off before I even graph that. Look at this and look at this. I noticed something. Hey, look, I've got the exact same slope. I've got different y-intercepts. When I graph this, down 5 over 4, when I graph this, it's going to be pretty much the same slope, just in a different, same line, different spot. 7/4 is going to be right here, but it's going to be parallel. So this is my tip-off that this is going to be no solution. So solve the system by substitution. So solving by substitution requires you, don't do that, I want this one. Whoa. Get one of the variables by itself. Hey, I've already got that. substitute into the old equation or the other equation, solve for the variable, plug back in and figure out the other variable. So if I look at this equation here, look, I've already got this y by itself. That's what I want. So I'm going to take this and put it right in here for y. So instead of having x plus 2y equals 18, I'm going to have x plus 2, but instead of y, I'm going to have what y equals. So if I distribute that through, x times 1/2 x is going to be just x minus 36, not 18, 36, equals 18. So this is going to be 2x. If I add 36 to both sides, I get 54. So a little division there, and x should equal 26. No, I'm sorry, 27. So x should equal 27. So when I put that back in there, I can put it back into either one of these equations. It doesn't matter which. So if I put it back in there, y equals 1/2 times 27 minus 18. Well, 1/2 of 27, I'm just double checking my work here. 1/2 of 27 is going to be 13.5 minus 18. 13.5 minus 18, that's going to be negative 4.5. So my solution is going to be 27, negative 4.5. So let's take a second and just make sure that I did that correctly. Looks good. Let's move on. So Matthew stopped for gas twice on a long trip. The price of gasoline at the first station was $2.56. The second station, the price was $2.65. He bought a total of 36.1 gallons and spent $94. How much did he spend at each spot? So now, we let X be the first station. How much gas he bought there. We'll let Y be the second station. So together, he bought a total of 36.1 gallons. And then he spent $2.56 at the first gallon. Be really nice if gas was that cheap. And then $2.65 at the second gallon. And together, he spent $94. So now, I can do this a couple different ways. I can do a substitution. I could do elimination. What I might do, just to be simple, is solve this, subtract y over, so subtract y. So this would be 36.1 minus y, and substitute that back in for x. So rewrite this as 2.56, 36.1 minus y, plus 265y equals 94. So a little work on the calculator gives me this is going to be 92.416 minus 2.56y. So like that. So I'm going to take 2.65y minus 2.56y. This gives me 0.09y. And then 94 minus 92.416. So minus 92.416 minus 92.416 gives me 1.584. And if I divide that by 0.09, I get y equals 17.6. So what this means is at the second filling station, he filled up with 17.6 gallons. The first one is going to be just 36.1 minus that. So that means at the first station, he got 18.5 gallons. So walking through, set up a variable for each one, and then set up your systems, and then solve them. So elimination. Elimination is nice if you've got the same thing in front of one of the variables, or at least opposite sides. So pick a variable. What do you want to multiply the top by? What do you want to multiply the bottom by? Multiply the top and bottom numbers by those things. Get rid of the variable by adding the two equations, and then take the variable out and figure out what you got left. So now if I look at letter A here, here's what tips me off. I've got +2, I've got -2. I've already got the same thing in front of y, but one's positive and one's subtraction. That's exactly what I want, because now I want to add these two. So when I do that, I get 6x. 2y minus 2y goes away. That becomes 0. And then 15 plus 9 is 24. All of a sudden, this becomes really, really easy to solve. 6x equals 24. Divide by 6, x equals 4. Now, substitute this back into one of these, I don't care which, and figure out what you get. So 2 times, if I do the bottom one, so you subtract 8, negative 2y equals 1, y equals negative 1/2. There you go. So 4, negative 1/2 is going to be your answer. So let's try this one more time. So now there's nothing in front of, there's not the same thing in front of each one. So what I'm going to do is I'm going to look at 2 and 3 here in front of x, and here's all I'm going to do. I'm going to multiply this top one by -3 and this bottom one by +2. And here's why I do that. I do that because when I multiply this, this is going to give me -6x on the top and +6x on the bottom. All right, and when I do that, I'll be able to add those and it'll go away. But I can't just multiply that. I've got to multiply everything by the -3 and the 2. So let's see, that's going to be -2y. This will be -48. This will be positive, I think it's 78. So now when I add these two, here's what's going to happen. 6x goes away. 12x, 2y, 10y. 78 minus 48 equals 30. So after all that noise, y equals 3. Now I can substitute this into this one, this one, this one, or this one. Doesn't matter which, and figure out my answer. So I like this one just because y, there's nothing in front of it. So if it said 3x minus y equals -24, 3x minus 3 equals -24. Add 3, add 3. 3x is going to equal -21. X is going to equal -7. So I think that's pretty straightforward. All right, let's do one word problem. So Sammy purchased basketball and volleyball that cost a total of $67, not including tax. The price of the basketball is 4 more than twice the cost of the volleyball. Find the price of each ball. So you got the cost of the basketball, and you got the cost of the volleyball. And you know that together they were $67. So here's the second part. The price of the basketball, $4 more than twice the cost of the volleyball. So you've got to take twice the cost of the volleyball plus $4 to get you the basketball. So this is a pretty straightforward, hey, look, I've got one variable by itself on its own side of the equal sign. So this is where I'm going to throw this in for here. So I'm going to substitute. So instead of b plus v, I'm going to write 2v plus 4 plus v equals 67. A little combining like terms, a little subtracting of 4. So if I divide by 3, v equals 21. So a volleyball is $21. So if I double that, it's 42 plus 4. So that's going to be $46 for the basketball. All I did was substitute it in. All right, that's all I got. Come talk to me if you got questions, and we will get this figured out. Thank you.